Let us do one problem based on this Malus law. What is it? Unpolarized light falls on two polarizing sheets placed one on top of the other. Okay, so unpolarized light falls on two polarizing sheets. Okay, falls on two polarizing sheets. Unpolarized light falls on two polarizing sheets. Okay, placed one on top of the other. Placed one on top of the other. Okay, what must be the angle between their characteristic directions of intensity of transmitted light? What must be the angle between their characteristic directions if intensity of transmitted light is 1/3 the intensity of incident beam, if I is equal to I0 by 3. Intensity of transmitted light is 1/3 the intensity of the beam. How will you do this problem? Well, let the intensity of the incident light be I0. The intensity of the the intensity of the beam transmitted by first polarizer be I0. Okay, so the intensity of the beam, transmitted by the first polarizer what will it be? From Malus law, if you call that as I1, it will be equal to I0 by 2, isn't it? If theta is the angle between the characteristic directions of the two polarizer, the intensity transmitted by the second polarizer by the second polarizer, what will it be? Transmitted by the second polarizer, what will it be? If you consider theta as the angle between the characteristic distance between the two polarizers, the intensity, if you call that as I2, it will be equal to I1, because that's what which is passing through, cos square theta, isn't it? But you already have I equal to I0 by 3. Okay, I have taken this as I2. Ultimately I2 is equal to I0 by 3. Okay, so I2 is equal to I0 by 3. So this is equal to I0 by 3. So what will be the value for cos square theta? Cos square theta, I0 cos square theta, isn't it? It will be equal to, sorry, I1 cos square theta, not I0. I2 will be equal to I1 cos, because from I1 you get it. Now you put the value of I1. I1 is equal to I0. I2 is equal to I0 by 2 cos square theta, which is equal to I0 by 3. So what do you get for cos square theta? Cos square theta will be equal to 2/3. So what is theta therefore? Find out the value for theta from here. So this is how you will be getting problems for your from polarization. You will also get problems from half wave plate and quarter wave plate. So please take down such problems, okay? So problem number 2, and please do it. A beam of plane polarized light, a beam, this is your test of plane polarized, a beam of plane polarized light is changed into circularly polarized light by passing it through a slice of crystal 0.003 centimeter thick, is changed to circularly polarized light, is changed to circularly polarized light, okay, by passing through a crystal, by passing through a crystal. What is the thickness of the crystal? 0.003 centimeters. Okay, you have to calculate the birefringence of the crystal, assuming this to be the minimum thickness that will produce the effect. Calculate the birefringence of the crystal. Calculate the birefringence of the crystal. So what is it that you assume? This, the minimum thickness that will produce the effect. This is the minimum thickness that will produce this effect for light. Here lambda is equal to 6 into 10 to the power minus 5 centimeters. So what crystal converts plane polarized light into circularly polarized light? Okay, what is it? It is what? What crystal converts the plane polarized light into circularly polarized light? It is a quarter wave plate. And what do we mean by birefringence of the crystal? We are calculating the birefringence. That means the difference between the refractive index of the O ray and E ray. Okay, so now try to do the problem and find the corresponding solution. The last problem, problem number 3. Okay, what is it? Plane polarized light is incident on a piece of quartz cut parallel to the axis. Okay, so plane polarized light is incident is incident on a piece of quartz cut parallel to the axis. Cut parallel to the axis. Okay. So find the least thickness for which the ordinary and extraordinary ray combine to form plane polarized light. Find the least thickness for which the ordinary and extraordinary ray combine to form plane polarized light. Plane polarized light. How will you do this problem? So what are the given parameters? Mu 0 is equal to 1.5442. Mu E is equal to 1.5533 and lambda is equal to 5 into 10 to the power minus 5 centimeters. So please proceed with this problem. The least thickness of the quarter wave plate you will find, you'll have to find which will produce the plane polarized light. Is that okay? So just proceed. Okay.